So before we get to the review, we're going to start with questions on page 92, 93, which is 2.1's homework. So what you need? No? 47. Let's take a look at 47. Oh, that's a fun one. All right, so 47, we have to solve the equation, and it's a radical. So we have a lot of squaring in our future. But I gave you a little bit of advice on this lesson about what you want to avoid. 2x minus 5. This quantity is to the third power, all under the radical. And then we have a minus 10 equals 17. So the idea is if you have more than one square root or any type of root in the problem, you want to get them away from each other. There's only one in this problem, so basically your idea is you want to isolate it. So you start by adding the 10 over. And then you have the square root of 2x minus 5 to the third power equals 27. Now that's a square root. There's nothing written in the index, so we assume it's a square root. Here you're going to square both sides. And yeah, I don't know what that is. I'm going to need a little calculator assistance on that one, guys. Hold on. 2x minus 5 to the third power equals what? 729. So now, instead of expanding this out, I would just go ahead and apply the cube root. Because I believe 729 is a pretty number, isn't it? What is it? 9. Alright, so 2x minus 5 equals odd root, so don't worry about plus or minus here. Equals 9, and then you're going to solve it from there. Add the 5 divided by 2, and you get x equals 7. But remember, we're not done. Once you get x equals 7, what's that extra step you have to take on these questions? You have to go back and check it, right? So this one's not too bad to check. You have the square root of 2 times 7 minus 5, so 14 minus 5 is 9 to the third power. And that's not going to be a problem because this is going to work back out to 27 minus 10, which is 17. So check. Good. All right. What else you got? Mm, 49. Nothing? No worries? 45. Similar in style where you're going to isolate that square root. Oh, that one's kind of gross. Gross, gross. All right. 45 has a 0.5x on one side of the equal sign. And then square root of 4 minus 3x plus 2. So this one's a little exciting. You're going to subtract the 2 over. And then this is the point in your math where you're going to square both sides. So it's kind of up to you as to how you approach squaring this binomial. Some people don't like the fraction, so they tried to multiply this by 2 before they squared it. That's okay as long as you also did that over here. I've seen some people do some crazy things with their work. So if you have a 2 in front of both of these, that's okay. I think we can just deal with the fraction here, though, guys. 0.5x minus 220 squared is a foiling question. So 0.5x squared, let's see. Let's go ahead and do decimals here, just because they introduce a decimal in their problem. And these decimals are all going to be, none of them are truncated. They're going to be, none of them are going to be rounded off and truncated. So 0.5 squared would be 0.25x squared. And then you have 0.5 times negative 2, so that's negative 1x. And then you'll have another negative 1x. You'll have minus 2x. And then negative 2 times 2 will be plus 4. And then over here, the square and the square root cancel each other. Did you get to this step when you tried this one? Okay. So you do have a quadratic. You're going to probably want to add the 3x and subtract the 4. Oh, this one won't be too bad. So right now you have 0.25x squared plus x. The 4's actually end up canceling. So while you do have many, many, many methods of solving this quadratic, I might suggest the one where you factor out a common term. I'm going to let you guys finish this one. So you're going to factor out a common term. You're going to set both your factors equal to 0. And a little heads up on this one. You're going to get some extraneous solutions is what's going to happen at the end of this one.
How did you get the negative 2x when
In the foiling, I don't know, did I mess that part up? Because that's always possible. Alright, so I had 0.5x minus 2 times another 0.5x minus 2. You know where I'm getting at now? I mean, it's still possible that I messed it up, though. Let's see, negative 1x plus another negative 1x. Okay. Okay. I feel like I have something weird on my answer key on that one, though. Yeah. Let me just take a peek. See what's going on here. I don't know. I think my answer key, I had some weird math on my original answer key. The end result is going to be the same. You're going to get 2 solutions, and neither of them are going to work. So, like, you're going to cross them out, and you're going to show me you get them. Apparently, you're not going to get what I got, because that's weird. I don't know if it's going to come out to that. I don't think it will. And then you're going to tell me that there's what solution. If you cross off all your possible solutions and you have nothing left, that means there's no solution. Okay. So the troubling part about that question, though, is like you have to go through and show me all this. So that's why I wrote a big note on the key. Apparently you're going to get a different answer than I did, but you still have to show all your work in process. Don't just say no solution and then think you're going to get credit for that. Yes, ma'am? Sure can. Let's see if I can do this one without messing up. Oh, 46 is a splendid question. All right. 46 has like my worst nightmare where there's more than one radical, and they're currently on the same side of the equal sign, and that's a no-go. So we need to do a manipulation move where we don't have that anymore. 3x minus 3. So this is your worst nightmare, having 2 radicals on the same side. So if I was you, I would just add this radical over here. So this becomes the square root of 3x minus 3, and then there's still a minus 3 here, equals the square root of 22 minus x. All right. Still not great news. You're going to square both sides. The right side's going to work out beautifully because the square and square root will cancel each other, but this left side's going to be a hot mess. So I usually don't have you guys write this out, but I'm going to this time. I'm going to write it out the long way of 3x square root of 3x minus 3 times another square root of 3x minus 3 minus 3. All right, this part that's a no-brainer for us. I'm just going to write down 22 minus x. All right, here we go. When you multiply a square root by himself, that's the equivalent of squaring it, so they just end up canceling each other out, and you get 3x minus 3. And then you have minus 3 of those square roots, plus another minus 3 of those square roots. So you're going to have a minus 6 of those square roots. And then negative 3 times 3 is a plus 9. Okay. So I'm not going to finish this question. I'll take you like one more step because I notice we still have a radical in our work, which means we're going to have to do the squaring process again. So you go back to your like warnings of you don't want anything with the radical if you can avoid it. So everything has to move away from the radical, meaning you want to move everything that's not the radical to the right side here. Let's go ahead and subtract 3x. And then I'm going to do kind of a cheater's thing here. I have a negative 3 and a plus 9, so that's like a plus 6, right? So I'm going to subtract a 6. I haven't done anything with this minus 6 in front of the radical, though. All right, so right now you have negative 6 times the radical square root of 3x minus 3 equals, yep, that's, oh my gosh, 16? Okay, good. 16 minus 4x. Yeah? Gross. Okay. You need to now decide what you want to do. Normally, I would say go ahead and divide by negative 6. Is that going to make my life easier, though? It really isn't. So instead of dividing by negative 6, I'm actually going to square this as it looks, and we'll worry about the 36 next. Okay, so I want you guys to keep working on this one. Your next step looks like this. Negative 6 squared is a 36. And then when you square the square root, they just end up canceling each other. This one you're going to need to FOIL out. You have quite a bit of work left. So you guys have a really lovely quadratic coming your way. If I look ahead to my answer, what number is this? 46. Okay, so I'll give you a little heads up. It's going to be a quadratic. You're going to solve and find two solutions. You can choose your method of solving it, guys, but like you've already done a ton of work. I might say just do quadratic formula at the end, but it's up to you. It does technically factor if you could figure it out. And then I'm going to give you a little heads up. One of your solutions is going to be extraneous, so make sure you go through the check at the end. All right, good luck. Have fun. That was a good question, though. So now you know what I mean by I need to see work on these problems, guys. These are not like a, oh, I can totally intuitively tell that the answer is going to be 3. Nope, that's not possible. All right, anything else on that homework? It does look fun, though. Have fun with that tonight. All right, let's talk about our review. So, I don't know, what do you want to start with? That little matching worksheet? Now, the matching worksheet has the answer key on the back, so try not to look. I don't have a smart file for this matching worksheet, so as far as the video goes, I'm going to pause the video, because you're just going to hear me talking for a while. We'll come back to the review. The answer key's on the back of that worksheet. If I was doing this worksheet, and I didn't have the answer key, the first thing I would do is I would maybe jot down what happened to that function. When I put a subtract 2 outside of a function, how does that shift? Up, down 2. Yes, you said down 2. Thank you. So I'm just going to jot down in words the transformation. So then the next one says f of 2x. So that's the weird one that we got confused on the last test. When there's a 2 inside the function, that is a horizontal, is it stretch or shrink? Or compression, if you want to use that word. A 2 inside is going to be a shrink or a compression. So this is a horizontal compression, which means all of your x-intercepts are going to be half as far out as they used to be. So I would write myself a little note, the x-intercepts change. You can even write a note about changing to half of what they were. That's fine. Just remember the horizontal shrink and compression and stretch are going to be opposite of what you thought. All right, number 3. This one has 2 transformations on it. There's a negative in front of your function, and then they have x plus 2 inside the function. So this is a vertical movement, and this is a horizontal movement, so they don't compete against each other, but can someone just remind me what happens when you have x plus 2? That's left 2, good. And then a negative in front of your function means that you've been reflected over the x-axis. Some of you are calling that a vertical reflection. I know what you mean by that. That's fine. All right, number 4 has a 2 in front of your function, and then there's also a negative x. So this is a vertical reflection, and this is a horizontal reflection. I'm sorry, this is a vertical stretch, this is a horizontal reflection. They don't compete against each other, so order doesn't matter here. You could say a vertical stretch of 2, which makes the y's go up twice as fast. And then this negative inside the function is going to reflect it over which axis this time? It's going to reflect horizontally, so what axis is that? The y-axis. Very good. All right, when I look at number 5, you have f of x, the whole quantity being divided by 2. Well, another way to write that would be having a coefficient of 1/2. So a 1/2 in front of your function means that you have a, you could call it whatever you want, but it's, I would say it's a vertical compression of 1/2. So all of your y values are going up half as tall as they used to. I'm going to move over here now. Okay, number 6, f of x minus 2. That should be an easy one for you guys. That means what direction? Right 2. Very good. So it's being shifted horizontally, right 2 units. Number 7 has 2 transformations on it. There's a negative in front of the function. That's a vertical reflection. So that's not going to compete with this next thing, which is x over 2. So remember, x over 2, also known as 1/2 x. Be careful here, guys. I know it's a reflection over the x-axis. But what would you call this transformation when there's a 1/2 inside the function? It's a horizontal stretch. Horizontal stretch. Horizontal things work opposite. And I'm going to write down horizontal stretch of 2. I think that's going to help you identify. Remember, horizontal stretch and shrink means that the x-intercepts will change. So in particular, that one x-intercept that we were trying to eyeball earlier, where it was like at -1 point something, it's going to be stretched by a factor of 2. So it's going to be at negative almost 3. But there's also that vertical reflection, so watch out for that. All right, number 8. This is the world's largest slide, sorry. Number 8 says f of -x and then plus 2. So again, this time we have a reflection across the which axis if it's inside like this? The y-axis, good. And then that's a horizontal movement. This guy's a vertical movement, so order doesn't matter here. So shift it up 2 and also reflect it across the y-axis. One more. Number 9. We have 2 in front of the function, -2. Now, we have a vertical stretch and you have a vertical down 2. These do compete against each other. So you have to be careful about the order in which you apply these visually or algebraically. The vertical stretch of 2 would have to be applied first on your function. The subtract 2 is what's happening after you've applied that. So you are looking for a graph that has been vertically stretched by 2, vertical stretch of 2, and then moved down 2. Now this might just be a game of like elimination. You've got everything else paired up except for that last one, and that's okay. Just remember, oftentimes when you have 2 competing transformations, you have to be careful about order. Hi, thank you. It's about tomorrow, I bet. All right, so I'm going to let you guys kind of have fun with matching those up. Like I said, the answer key's on the back. Thank you, Mrs. Hoffbauer. She even wrote you guys some notes about how you can tell with the horizontal stretching and shrinking. I think that's probably one of the most difficult things for kids to identify is the horizontal stretch and shrink. So pay close attention to those. All right, now let's talk about your review. So you have F, G, and H at the top of that review, or sorry, at the side of your review. And we're going to use those functions to answer a whole bunch of questions here. So the first question, they're going to have you state the domain in interval notation for f of x. So here's f of x. And I know for domain, the things I watch out for algebraically are any denominators with x in them. We don't have that. And then you also have an even radical to watch out for. We do have an even radical this time. So the domain for a problem that has an even radical, whatever is inside your radical, since we don't work with i's in this chapter, it has to be greater than or equal to 0. So you would have to kind of set up x plus 1 must be greater than or equal to 0. And if you solved that, you'd get x is greater than or equal to -1. But look, interval notation. So make sure you're giving me proper interval notation. All my numbers that are greater than or equal to -1 would start at -1 with a bracket and go to infinity. You guys are welcome to graph it on your graphing calculator. You could graph the entire function and you'll see it'll be a square root graph has been reflected and then shifted down, well, left 1 and down 3. And you're going to see that same domain. It's just a lot easier to find the domain algebraically if you don't have to pull up your graphing calculator every time. And time is always the issue on pre-calc tests because, you know, it's timed for a child who knows what they're doing. A child who has to kind of tinker with the problem for 10 minutes is not going to have enough time to finish the test. All right, f plus g, or sorry, f plus h. So f plus, where's h? Down here. This is kind of weird. F is a very strange function. Negative square root of x plus 1 minus 3. And you're supposed to add that to h, which is 2x squared plus 4. And technically, I'm not going to be happy with that answer because I would expect you guys at the pre-calc level to simplify. So the only thing you're going to have to do, guys, is combine these constants together. Terms can be in any order. Most kids choose to put the square root in the middle, but it really doesn't matter. So 2x squared minus square root of x plus 1. And then I can add, right, plus 1. So some variation of that combining of like terms, the terms don't have to be in that order at all. I just do expect you to simplify. All right, number 3, g times h. So here's g, and here's h, and you guys are supposed to multiply them together. So you're going to not run into that issue that Algebra 2 kids have. They always forget parentheses, but you guys don't. You're pre-calc. Negative 4x plus 5, that quantity is being multiplied by 2x squared plus 4. Pre-calc, you're better than this, right? We can simplify this answer. So negative 4 times 2, so negative 4x times 2x squared is negative 8x to the third. And then we have what? Minus 16x plus 10x squared plus 20. And I know my terms aren't quite in standard form. I don't think the directions ever said like you must write your answer in standard form, but it is an implied, like I expect you to simplify. There's no like terms to collect here, guys, so this is an okay answer. I am assuming if you looked at my answer key, I probably flip-flopped these terms, but whatever. Oddly enough, I'm really worried about number 4. So I have h, which is 2x minus 2x squared plus 4. And we're subtracting g. And this is how I get a lot of kids writing their problem, and then they wonder why they got it wrong. Anyone want to tell me why they're getting it wrong? They're not going to distribute the subtraction all the way through, are they? You got to remember that you're subtracting the entire function g. So this becomes, let's see, 2x squared, and then you're going to have a plus 4x here. But this 4 is going to be combined with what is really a minus 5. So you're going to have a minus 1 on your constant. So just be careful, and, you know, I know time is always of the essence on these tests and you're stressed out, so you make silly mistakes, but there's ways to avoid silly mistakes, and you're using parentheses and not skipping that step would be a great way to avoid that mistake. All right, next question is composition. It says g of h of negative 6. So another way to write that question in a notation that you might be happier with is g of h of negative 6 like this. So you are doing composition. However, since you're composing at a number, a much easier way to do this question would be to start here. So if you found out h of negative 6, that would be 2 times negative 6 squared plus 4. Okay, it's practically a Monday morning for me, so I need a little assistance here, guys. That's 36 times 2, 72 plus 4, 76. So this thing right here is really 76. So now they want you to find g of 76. All right, let's figure that out. So negative 4 times 76 plus 5. Okay, I give up. I need a calculator now. Or at least an answer key. Is it negative 299? Yay. So that final answer you get through the composition, that is your solution or your evaluation for that composition. All right. So here they want you to compose a function. So we're not going to have a single number answer. It's going to be a new function. And then because of the nature of the function, we're going to see that there's a domain restriction on it. So g of f, goff. If you don't like that notation, you can change it for this. But the idea is you're going to start with function g, which is this guy. And in place of all of the inputs, you're going to put this guy. So 1 over, instead of x minus 8, I'm supposed to put all of this in place of x. Super. Okay. So that's not simplified clearly. Let's do a little simplifying here on the denominator. I have 1 over 2x squared minus x minus 3. So that's as simplified as you can get for your function for now. But we do have to talk about domain restrictions. So we talked earlier about a restriction when you had a radical, an even radical, but now we have a denominator. So we have to think, okay, my denominator can't be equal to what? Can't be 0. So that means I need to figure out, well, it'll make it 0 and say it can't be that. If you think about your factoring, this one actually factors really nicely. So like 2x and x. Let's see, how about a minus 3 and a plus 1? Because that'll give you positive 2x and a minus 3x in the middle. Now remember, these factors can't be equal to 0 because those are domain restrictions. So like this one here would say x can't be 3/2 when you solve it. And then this one here obviously would be x can't be -1. So that was a little more complicated than the last couple domain restriction questions we've tested you on. The last few have been like really simple linear ones where you just add and divide. This one you might have to do a little factoring. It's okay, you got this. Okay. Draw a function that is 1-to-1 and explain why and what it means to be 1-to-1. So you're going to show me some words that involve like test. What two tests are we applying for it to be a 1-to-1 function? A vertical line test and horizontal line test. So the easiest one I can come up with is just a normal cubic function. I called it a function, which was a bit of a spoiler. But since the original one passes the vertical line test, that means the original is a function. And since the original also passes the horizontal line test, that means his inverse would be a function. So when you have a 1-to-1 function, the easiest way to test for it would be to apply the horizontal and vertical line test. And then what that means is the original is a function and the inverse to that is also a function. And then we're going to find the inverse. So the most basic idea about finding inverses, or any inverse functions, are that the x's and y's switch, which of course means a lot of other things switch too. So we know that this is really y equals negative cube root of x minus 1 plus 3. So when you go to find the inverse, you start by switching the x and y. Actually, you know what, I kind of skipped a step. I should have checked to see if this was even a 1-to-1 function. It is, by the way. So we're going to go ahead and find the inverse by switching the x and y. Oops, except I didn't do that. And then you're going to do some algebra to solve for the y. So I'm just going to subtract the 3 over. And I'm not going to do a ton of simplifying in this function, guys, because I'm not actually doing anything with this function other than finding it. So when I have the cube root of y minus 1, there's a negative in front of it, so I'm just going to divide each side by a -1. Or multiply each side by a -1 if you want to think of it that way. Negative x plus 3 is fine. Some of you are going to switch that order though, so instead of saying negative x plus 3, you're going to write down 3 minus x. I do not care. And then we have the cube root of y minus 1. This is where we can kind of take shortcuts because of the nature of the question. I know I'm supposed to cube both sides, so I'm going to, but I'm not going to actually follow through and expand that binomial. I'm just going to leave it as quantity to the 3rd power. So almost home free here, guys. You have 3 minus x quantity to the 3rd power equals y minus 1, and then your last step would be to add 1. Now, we don't call this y. What do we call this function if it's the inverse of this original function? G to the inverse. Yes, inverse of g. So g to the -1 of x. Very good. And then you said it was the 3 minus x quantity cubed plus 1. Lovely. That one took a lot of manipulation, but we got y by itself. Okay, let's take a look at the next one. This one's going to take a lot of manipulation as well, so hopefully you have some room. All right, same idea, guys. We want to switch the x and y around. So remember, that's really y. So when you switch the x and y, you get x equals y minus 5 over 2y plus 3. But all of your algebra is trapped in a proportion right now, and there's more than one y in the problem, so this is one of the problems where you have to kind of free up the algebra by cross multiplication. So I'm going to multiply both sides by 2y plus 3. So right here, this diagonal is 2xy plus 3x. And then this diagonal's boring. It's just 1 times y minus 5. So once you switch the x and y, your job is to get the y isolated. But we have a problem here, y'all, because there's too many y's in the problem. So when this happened in Algebra 2, you got everything that had a y to one side of the equal sign, and everything that did not have a y in its term to the opposite side of the equal sign. So that's what we're going to do. I'm going to subtract this y over. I'm also going to subtract this 3x to the right. Not the only thing we could have done just now, though. Some people moved y's to the opposite side. It doesn't matter. So 2xy minus y, those are not combinable terms. So you're just going to write 2xy minus y. And then here, gross. You have negative 3x minus 5. It's okay. It can be gross. Okay, a little trick from Algebra 2. When you have more than one y and you need to isolate the y, once they're grouped together, you can factor the y out. So factoring out that common y, you get 2x minus 1. All right, home free. One more step would be to divide both sides by 2x minus 1. But please don't forget this is actually a very crucial step for PreCalc, guys. You can't call this y equals because that's not the name of this function. The original function was called f of x, so his inverse function would be f to the negative 1 of x, or inverse for f of x. Now, you do not have to worry about whether or not you have the correct answer versus a person who collected terms differently. Like, I'm able to manipulate that answer multiple ways, so I know if you have an equivalent answer. You guys don't have to worry about that. Like, for instance, if you worked ahead on this, if you got 3x plus 5 over 1 minus 2x, that's equivalent. So you don't have to worry about that. Okay, I can graph a function and its inverse. Easiest way to graph the inverse is to find ordered pairs and flip-flop them. Now, before I start graphing, the other thing I like to do is I like to draw a little highlighter line, kind of, sort of, through the line y equals x, because this is the reflection line for inverse functions. I am not good enough at visualizing art to know what the reflection will look like before I plot any sort of points. So what I'm going to do is I'm going to come up with what I think this ordered pair is. What do you guys think this ordered pair is? It's like really close to negative 5, isn't it? Okay, so instead of 0, negative, let's just call it negative 5 for easiness. I flip-flop the ordered pair. I'm going to plot negative 5, 0. Or something really close to negative 5, 0. And then, like, I don't know, what's this ordered pair right here? This is the ordered pair for negative 3. So I'm going to plot the ordered pair negative 3, 4. And maybe that's enough for you to get a visual on this. Maybe you need a third point. If you're not real great at visualizing like me, you probably want a third point. So I'm going to go ahead and graph this guy, which looks really close to 8, negative 2. So I'm going to plot negative 2, 8. Okay, that's better. Except that I come through and ruin it with my terrible graphing. All right, so squint. Does it kind of look like it's a mirror image across that green line? Yeah, sure. We'll go with that. Oh, that was ugly. All right, new stuff, newish stuff. So you have a power function. And for the sake of time, I'm going to kind of spoil this for you. If you were to graph this on your calculator, it looks like this. Kind of. I'm doing a terrible job of graphing again. What's new? So this is a rational function. Clearly there's some domain interruptions and a range interruption, if you want to think of it that way. So when I ask you for the domain, you better not tell me it goes forever to forever, because there's a big break in the middle. So the domain, while it does start at negative infinity towards the left, where does it break? At 0, I heard. Thank you. So you can't use 0. It's a discontinuity. So hop over 0 by giving me this notation. Notice I used parentheses because 0 cannot happen. You cannot have 0 there. If you want to think of why you can't have 0, this is your true function. X to the negative 5 you could throw to the denominator. Can you have 0 in your denominator? No, we can't. That's why the domain has an interruption at 0. Now the range is a little more difficult to see algebraically, but visually I can tell that there's a break right here in the range, which also happens to be at 0. So the range goes from negative infinity to 0, jumps over 0 because there's a break, and then goes up forever. Excuse me. Intercepts. Does it cross the x or the y-axis? No, so you can just say none. It should be an easy question. Is it continuous? No, it is not. And then end behavior. I know I'm being asked about the left and the right end behavior, so I'll fill those out real quick. But when I look on the left side, this is the left behavior, your function is coming down to this asymptote, so it's approaching what y value? 0, good. And then on the right end, your function's coming up to this asymptote, which also happens to be at 0. Now this is the part I'm a little concerned about. Increasing and decreasing. So there's two parts to this roller coaster if you want to think of it this way. There's this part and there's this part. Can y'all see, ignore the arrows, can you see that that's an increasing roller coaster track right there? And then this other part of the roller coaster is also increasing. So I get kids who say, oh, it's increasing from negative infinity to positive infinity. And that's a no, because there's a break in the middle of that domain. So you're going to tell me it's increasing from negative infinity to 0, and then on the other side of 0 it picks up again. Is this roller coaster ever decreasing? Never. So just say never. All right. Woohoo. Oh, these. That first one's pretty easy, guys. You can check out the key when I post it today to figure out how to do that one. But let's talk about the second one. This is like the one that good thing we did some homework questions this morning. You are going to square both sides. But you're going to be careful when you square this guy. And I don't usually write out the binomial separately like this, but I'm going to this time because this is where kids mess up. This right side of the equation, though, that's just x minus 45. That's nice. Okay, square root of x times another square root of x is x. Thank you. That's right there is where kids mess up. It breaks my heart. So here we have negative square root of 3. Negative 3 square roots of x plus another negative 3 square roots of x. So you have negative 6 square roots of x. And then negative 3 times negative 3 is plus 9. So you have that issue where there's still a radical in your problem, so you got to isolate that radical, and then we're going to have to square again. So, oh, this is kind of nice, though. The x's cancel. I'm going to go ahead and subtract the 9. So I have negative 6 square roots of x equals negative 54. I know you guys are looking at me like I should be able to subtract those, but I can't. All right, and then you can go ahead and square both sides right now, or I would just go ahead and divide by negative 6. Because I think that comes out kind of nice, doesn't it? Is that 9? Yeah. So now I would square both sides. And this one came out really quite nice. You get x equals 81, but we're not quite done. Why? You still need to go check this. So you'd plug 81 back in. Good news, it does work. If for some reason it didn't work, you would just gently cross it off and say extraneous, but this is not one of those problems, so you will say x equals 81. The next section is all review. It's more transformations. So what we're going to do tomorrow is we will go over those questions in particular, but I have other stuff for you to work on tomorrow. So your job tonight is probably to look through the rest of that review, make sure you don't have any existing questions, make sure you can do those independently, and then make sure that homework check is done because that is going to be due for us tomorrow, please.